with stress concentration. Okay? So, how do you know kapag meron po na stress concentration? Only if the member comes with surface discontinuity, which are what we call the stress racers. Okay? So, stress racers, that includes the hole, the fillet, and the groove. Okay? So, sample po nun. So, for example, we have here po our machine member. Yan. So, for example, this is our machine member and then loaded with a variable force. Okay? So, yung variable force meaning nagva-vary po yung force na ina-apply. Say 5, 10, 15, 20, then go back to 5. Yan. Okay? So, nagva-vary po yung force na ina-apply natin. Now, you would see there, okay, so the surface of the member comes with a surface discontinuity. So, for example, katulad po nito, it has yung hole. Okay, this one naman po, this is called your fillet, a sudden reduce of the cross-section. And then this one, we call it yung groove. Okay, so these are what we call stress racers. And from the word itself, stresses are concentrated on that area, making that area now weak. So, failure would mostly like or would most likely to occur doon sa mga areas po na yun. Okay? So, there are other types of stress racers such as yun pong cracks. Okay? So, cracks are also stress racers. Same thing with blowholes. Okay? So, blowholes, these are yung trap na mga air doon po sa atin na glass. Okay? So, halimbawa, along the thickness of the glass, meron ka dito nakitang parang na-trap na air. Yun po yung tinatawag natin as the blowholes. These are also stress racers. But then, these are different from these three. Okay? Alin po kasing tatlong nauna, these are necessary on the design. Katulad po niyan, ay ganyan kailangan yung itsura niya. Okay? So, it comes with the fillet, with the groove, with the hole. Yan. So, need po siya or parte po siya ng design. Not unlike the crack and the blowhole, which are simply results of yung habang fina-fabricate mo yung machine member. Halimbawa, sa nagkaroon ng damage during the fabrication, so nagkaroon na may natrap na air, so nagkaroon ng blowholes. But they are not necessary na naandoon sa machine member. Not unlike this three. Okay, para po yung ating ginagamit na mga monoblock chair. Di po ba yung likod niya may mga butas, okay? So, ano po yung gamit noon para sa air circulation? Okay? Para hindi masyadong mainit po sa likod natin. So, may purpose na nilagyan talaga siya nung mga butas na gano'n. Okay? So, yun po yung sinasabi ko na stress racer na parte ng design. Needed doon sa design. Okay? So, although these are stress racers, okay, nagiging weak yung parte ng material na yun doon sa design, but then they are necessary. Hindi pwedeng alisin kasi they serve a function. Kaya ang gagawin natin on our design, pag kinompute natin ang dimension ng member, edi dapat i-account po natin yun. Okay? Kasi hindi natin siya pwedeng alisin. Okay? So, yun po yung principle po nito sa variable stress analysis with the stress concentration. Okay? So, how do we design these members? Okay? How do we design these members? Okay? So, ganun pa rin po. Okay? Since variable stress po, ang gagamitin pa rin natin is the Soderberg and the Goodman equation pa rin. Okay? So, we recall the Soderberg. Okay, 1 over Fs, okay, equal to sigma m over sigma y plus sigma a over sigma n. Okay, Goodman, we have 1 over Fs equal to sigma m over sigma y u plus sigma a over sigma n. Soderberg, this is used for ductile materials, whereas Goodman for brittle. Okay? And then, this has another form, yun pong in form ng tau. So, same format po ng equation, only lahat po ng sigma, palitan natin ng tau. Tau m over tau y plus tau a over tau n. Same thing with this. 1 over fs equal to tau m over tau u plus tau a over tau n. Okay? So, yan pa rin po yung ginagamit natin. Okay? Yung tau, again, is for shear and torsion at yung sigma is for axial at saka po bending and thin wall. Okay? So, yan po yung mga ginagamit po natin. Okay? What is only its difference kung meron na po tayong stress concentration? Okay? Yung po pag may stress concentration tayo, yung ating pong stress ratio na yan is to be accounted. Kaya nagdadagdag po tayo ng factor sa Soderberg at sa Goodman equation. So, we include here po on the second term, okay, KF. So, ari po yung idinadagdag natin, KF or KFS kapag po tau. Okay, so we include here KF and KFS. So, yung equation natin ngayon may dagdag na, okay, to take care of the stress ratio. Okay, so yan na po yung nadagdag. So, yung KF po, ang tawag po natin sa kanya is fatigue strength reduction factor. Okay, so this is fatigue strength reduction factor. Kung siya po yung KFS, fatigue strength reduction factor in shear. But then basically, they are just the same. Okay? The same lang po yun, even their equation. So, to obtain the factor, Kf is equal to Q times Kt minus 1 plus 1. Okay? So, ito po yung equation natin. And this is even equal to your Kfs. Parehas lang po sila. Okay? So, ano po yung Q, ano yung Kt? Okay? To obtain your Kf. Yan po kasi yung nadagdag sa Soderberg at Goodman. Yung Q po, you call this the notch sensitivity factor. Okay, so this is called the notch sensitivity factor. And this can be obtained using, okay, figure AF7. Okay, everybody, you get your design table po and you use, you look for figure AF7. I think that is on page 21. Okay, pakitingin nga po. Page 22 po pala. Palitan pala ka rin. So, page 22. Everyone, you have with you yung tables po natin, okay? And then see figure AF7. Okay, ito po yung AF7. Paano po siya ginagamit? So, gagamitin po natin siya to obtain the value of Q. Okay? So, yung Q po, this is called the notch sensitivity factor. There are two ways on how you obtain the value of Q. First is using figure AF7. Okay, or look at figure AF7. So, dito po sa x-axis, we have here the notch radius. Halimbawa po, yun po ating problem has yung central hole. So, kukunin mo lang po yung radius na yon. Halimbawa, diameter po is 1/8. So, common mistake, yung 1/8 ang hinahanap dito. Okay? Again, this is the radius po. So, if diameter of this is 1/8, okay? So, 1/16 yung kanyang radius. Divide by 2. Okay? And then, dito po makikita mo, may tatlo po na curve. Okay? Yun pong isa, okay? Ito pong isa, dotted, okay? Or dashed. Yan po ay exclusive for aluminum alloy. But then, for other steels po, okay, ito naman po yung gagamitin. Ito pong una is for quench and tempered. Halimbawa, ang given material is 2330 water quench and tempered. So, you will use this. Okay? Kapag po naman siya ay annealed or normalized, edi ari pong pangalawa. Paano po ma'am kung wala, hindi po quench and tempered, hindi annealed, hindi normalized na steel? Ano pong gagamitin? Meron po din nakalagay, BHN, okay, BHN less than or equal to 200. Okay, so ibig sabihin, aring pangalawang curve, pwede rin po natin gamitin. Kahit po hindi siya annealed or normalized, but BHN is less than or equal to 200, pwede po ito din yung gamitin po natin. Okay? And yun naman pong isa, okay, ari naman pong quench and tempered, pwede naman po natin yung gamitin if BHN value is greater than 200. Okay, kasi yan lang pong dalawa ang para sa steel. Hindi po natin pwedeng gamitin itong sa aluminum alloy. Okay, so we can assume to use this value, quench and tempered, kapag ang BHN ay greater than 200. Okay? So, paano po siya gamitin to obtain yung value ng R? Anong atin pong Q? Okay? The notch sensitivity factor. Dito po natin siya makikita sa y-axis po. Halimbawa po, radius po is 1 over 16, tapos quench and tempered. So, you have this point po. Okay? And then, i-read lang po natin siya dito po sa atin po na y-axis. Okay? So, what is now the value? Ano po ang ating approximate? So, i-estimate lang po natin ano po ang value. Anyone, how do you estimate this value? Hello? 0 point? Yes. Van? 0.95. O, ano po yung value? Medyo napababa lang yung lagay ko. Parang hindi naman 0.95. Okay. Anyway, if that is what you think, okay, so ilagay natin 0.95. Okay? Again, that is an estimation. Yun po yung una pong procedure. Okay? Yun po yung unang way on how you obtain the value of Q. Ang another one po, okay, is using an equation. So, may equation po tayong gagamitin. And I suggest that you make use of this po. Okay? Kesa po din sa nauna. Okay? Ari po, makikita po natin sa figure AF7, meron po dyan equation. Ito pong bandang ito. Ayan. Okay? O, tingnan nyo po, ari. Ayan. Ito po yung equation ng Q. Ayan na lang po yung gamitin natin. Okay? Q is equal to 1 over 1, okay, plus A over R. Okay? Ito po yung equation. 1 over 1 plus A over R. R again would be the notch radius. So, kung yung sample po natin, yung pa rin yung 1 over 16. Ano lang po yung A? A is a constant for a type of material. And we can see the value of A po dito din sa figure AF7. Ano po? For aluminum alloy, you have their A is 0.025. Kapag po annealed or normalized, 0.01. Kapag po quench and tempered, 0.0025. So that applies also to the BHN value. Kung ang material po ay may BHN less than or equal to 200, ari pa rin po yung kanyang A. Pag greater than 200, ari pa rin po. Nakuha po ba? Hello? Yung BHN lang po, gagamitin lang po natin yan kung hindi po siya pumasok dito sa classification na to. Quench and tempered, annealed, normalized. Maliwanag po ba tayo doon? Hello? Okay, now, you try now to solve. Okay? You try to solve. Okay? Ano ba yung ating gagamitin na A dito? 0.0025 for quench and tempered steel. Kanina, using figure AF7, sabi natin 0.95. Okay? We estimate the value as 0.95. Kung kukunin na natin yung Q using the equation, ano naman yung magiging sagot? 1 over 1 plus A is 0.0025. Ano yung radius natin? 1 over 16. So, try to see the value. Ano po yung value natin? Again, anak? Ano na lang? Decimal. Point 0.9615. Okay. So, 0.9615. O, idugtong na lang po yung mga kasunod pa na number. Okay? So, thank you. So, yan po yung value ng Q. And what we have to estimate is 0.95. So, ito po will give us a more exact value. So, kaya nga po, better to use yung second method po, to use the equation. And your figure AF7, gagamitin mo pa rin naman po. Saan mo ginamit? Doon sa equation, you can copy the equation for figure AF7. Same thing with the values of A. Okay? So, galing po dito mo madidetermine ano yung A na gagamitin po natin. Okay? So, you refer again to figure AF7. Okay? So, yan po yung Q. Okay? Na ginagamit po natin para ma-solve po yung KF. Okay? Yun naman pong KT. Okay? Saan naman po manggagaling yung value ng KT? Okay? So, ilagay ko lang po ulit din you use the equation 1 over 1 plus A over R. Okay? Yung A po, manggagaling din sa figure AF7. Okay? Now, let us have the value of KT. Ano naman po yung KT? Ang KT po, ang tawag po natin diyan is theoretical stress concentration factor. Okay, so KT is theoretical stress concentration factor. And we will be using here figure AF8 up to figure AF14. Yan. Ari po yung gagamitin natin to obtain the value of KT. Okay? So, paano po natin kukunin yung value ng KT dyan? Okay? Sa theoretical stress concentration factor. O, puntahan po natin yung AF8, 9, 10 hanggang 14. Yan. Yan. Ang AF8 po, may kanya-kanya po siyang specific na description. Okay? Yung AF8 po, gagamitin mo if you have there a flat plate with a central hole. Katulad po nung nasa illustration. Okay? May flat plate po tayo, tapos may hole po doon sa gitna. Okay? The diameter of the hole, you have there D. Okay? And the dimension of your flat plate, ano-ano po yung dimension? You have there the height, at saka po itong thickness D. Okay? So, if you take the cross-section po, ano pong aking sinashade, ayan po yung dimension, yan po yung cross-section ng ating flat plate. Having dimensions H and T. Okay? H and T po. Okay? So, usually po sa design, it is the dimension na hinahanap. So, most probably po, H at saka T po, yung papahanap po sa atin kapag po ganyan. Okay? Dito naman po sa AF9, the same flat plate po, lamang may ibang ano po siya, stress razor. This time, fillet po yung stress razor natin. Okay? Ano po yung dimensions niya? H, D, at saka po yung T. Okay? Yan po yung dimension ng member. AF10 is still a flat plate, but this time, it is with a groove. Okay? So, with a groove naman. Okay? Ito po yung kanyang stress razor. AF11. Okay? Flat plate with eccentric hole. Okay? Ito naman po yun. So, flat plate pa rin siya, and then yung hole lang natin ngayon, hindi naka-gitna. Okay? It is at any position na hindi lang gitna. Okay? Yan po yung eccentric hole. AF12, papalitan na po natin yung cross-section. So, hindi na po siya ngayon flat plate, but instead, circular na yung kanyang cross-section. Okay? So, AF12 is a shaft with fillet. Okay? Ito po yun. So, anong cross-section, anong kanyang dimension? Yung big letter D at yung reduced diameter, small letter D. Okay? Next would be shaft with a radial hole. Okay? Ito po naman yung shaft natin. Dimension niya is the diameter D. Nasa naman po yung kanyang radial hole na sinasabi. Okay? Nasan po yun? Yung hole niya po, nandito po sa tuktok. Okay? Nandito po yung hole niya. Okay? And ito pong D na to, small d, refers to the diameter of the hole. Okay? Yan. And then last po is shaft with groove. Okay, ito po yung shaft having a diameter D, original diameter, tapos ito po yung kanyang groove. So, ang gagawin nyo lang po is, you take a look at the problem, okay, na sinosolve po ninyo, and then try to compare it with figures from AF8 up to AF14. Tingnan nyo lang po, alin yung katulad doon. Okay, alin lang yung katulad. Yung AF8 up to AF14, it varies with yung kanyang cross-section. Yung isa, circular, yung isa naman po, flat plate. Okay? At ang ano pa yung kanyang variation, different naman yung kanyang stress razor. Okay? So, kada stress razor, may particular figure ka po na gagamitin. Okay? So, pag razor po yun. Okay? Hindi po pwedeng barkadahan yung stress razor. Isa-isa lamang po. Okay? Kasi yun lang yung nando sa figures po natin. Okay? So, ganun po natin gagamitin. Okay? Pipiliin mo muna. Now, how do you obtain the value of KT? Halimbawa po, din tayo sa sample natin, AF8. So, flat plate with a central hole. Okay? So, ang titingnan mo lang muna po dyan would be the x-axis. Okay? So, yung x-axis niya po, this is D over H. Okay? Ratio between the diameter of the hole and yung height po ng flat plate. Okay? So, you need to know first this D over H. Tapos, dadalhin mo lang po dito sa mga curve na yun. Okay? Yung curve po natin, dalawang klase, dotted at saka yung solid. Yung solid, nakalagay po doon, force acts on part. Meaning, yung forces po natin ay applied doon sa magkabilang dulo ng atin na flat plate. Okay? So, yun po yung gagamitin natin. Pero kung ang forces po are loaded on a pin in the hole, meaning dito po naka-apply mismo sa hole, ang gagamitin po natin yung dotted po. Okay? And yung sa dotted po, may iba-iba pang classification. May ilan po ito? Tatlo. Yung isa, B over H is 0.35. Ari po, B over H, 0.5. Ari po, B over H is 1 or more. So, you need to solve first for B over H bago mo isipin kung alin ba dyan ang gagamitin mo po na curve. Okay? Ang B po would be the distance of the center ng hole to the leftmost part of your flat plate. Okay? So, yun po yung B. So, you need to solve it first before po you decide on kung alin yung gagamitin mo po na curve. Okay? Now, for the value of KT, ang KT po, mababasa natin sa kaliwa, pwede din po din sa kanan. Okay? Pag ang ginamit mo po ay dotted curve, ang basa mo po sa kanan. Pero pag ang ginamit mo po ay aring solid curve, ang basa mo po ay sa kaliwa. Okay? Ganun po natin gagawin. Halimbawa po, ang ating pong D over H is 0.1. Okay? Tapos, dadalhin mo po doon sa solid curve, for example. So, saan po ang basa natin? Dito sa kaliwa. So, ano yung nabasa natin na value ng KT dito? KT is equal to 2.7. Okay, yun po yun. Okay, nakuha po ba? So, yun naman po may kaliwat kanan ay dinilang sa figure AF8. Dini po sa mga kasunod, AF9 hanggang 14, iisa naman po. Okay, lahat ay nasa kaliwa na lang yung reading po natin. Need mo nga lang po hanapin kung alin curve ang iyong gagamitin. Okay? So, ganun lang po siya ginagamit. May question po ba sila? Wala po? Hello?
Wala naman po.
Okay, wala. Now, you look again doon sa atin po na x-axis. That is D over H. Okay? You look at this ratio, that involves po yung H. Okay? H is the height of the flat plate, which is the dimension of your flat plate. So, possible that yung height po na yan yung unknown. O kaya yung thickness na yan yung unknown. Okay? So, if H is unknown, wala po tayong makukuhang ratio kasi wala kang value ng H. So, paano ka po pipili dito? Okay? So, yan po yung nagiging problema. Okay? Kasi yun nga pong height, yun po yung unknown. So, wala kang ratio na makukuha para makakuha ka ng value ng KT. Okay? No factor na KT. Okay? So, ano po ang gagawin natin kapag ganoon? Okay? So, para po makakuha tayo ng value ng KT, you need to assume a value. Okay? So, mag-a-assume ka po ng ano. Okay? Say, you assume a value of h. Ano yung a-assume mo na value ng h? Pwede po kahit anong number. Okay? Kahit anong number po na h, yun po ay pwede natin i-assume. Kailangan lang nga po ay makatotohanan. Okay? So, later po, dun sa sample problem natin, okay, tingnan po natin, okay, kung paano tayo mag-a-assume ng dimension. Okay? So, hindi po basta lang nag-a-assume na parang ano na nang huhula lang na parang ano ba yun, basta na lang, okay? Pero dapat naman po, it should be, meron pa rin tayong scientific approach on how to assume for a value. Okay? So, pag kinuha mo po yan, nag-assume ka po ng h, so therefore, makakakuha ka po ng value ng KT. Okay? Kasi na-solve mo po yung d over h, so makakagraph ka po dito, okay? Tapos makukuha mo yung value ng KT. So, nag-assume lang po tayo for purpose na makakuha po nitong KT. So, ang gagawin mo po, yung inyong assumption na yan, babalikan mo po. Pag may answer ka na po, may final answer ka na, titingnan mo ngayon, is your answer the same as what you have assumed? Okay? If they are the same, then this is your final answer. Okay? Kung parehas po sila. Pero kung ito po yung inassume mo, tapos yung na-solve mo po na answer, malayo yung value, ibig sabihin, ay hindi pa po yun yung final answer. You need to recompute. You need to have another assumption. Okay? So, yun po ang ibig sabihin niya. Now, sabi nyo, malayo naman po or para naman po mahirap na magkaparehas yung kanilang value. Okay? So, ibig sabihin lang po na parehas yung value niya, it would be the same, okay po, the same po yung standard size na gagamitin para sa kanila. Okay? Hindi naman po ibig sabihin na, ano po, nag-assume po ako dito ng 1, kung ang na-solve ko po is 0.995 or 0.96, okay? Magkaiba po yun, okay? Pwede mo na po yung tanggapin since ang standard size po nila ay parehas na 1 inch, okay? So, tatanggapin mo lang po yung value kung parehas po yung inyong parehas po yung kanyang standard size, okay? So, yun po yung tatandaan natin, okay? Question po ba? Wala naman. Okay, so I'll continue. Okay, now we have here po, what if we have po yung ganito? Ito po yung ating sample. Say, you have here po a shaft. Okay, so shaft po natin with circular cross-section. And then, meron po tayo dito na central hole din. Okay, so ito po naman ngayon is a shaft with a central hole. Okay, so the dimension includes, this is the diameter of the shaft, and then big letter D, and then for the hole po, we use small letter D. Okay? Ang tanong ay, alin po ang aking pwedeng gamitin dyan para kuhanan ko ng value ng KT? Okay? So, pipiliin po natin from figure AF8 up to AF14. Okay, so hanap po natin alin yung katulad. Okay, so basically, wala po yung makikita ka na shaft with central hole doon sa AF8 hanggang AF14. So, ang gagawin mo lang, alin yung katulad niya. Okay, tingin nyo nga, alin yung pwede natin magamit para sa kanya.
Specification, meron bang system component? Dapat yung i-discuss dito sa consultation. Kung ano yung mag-base na kung mag-register sa kasi design. Kasi yung mga system components. Kung ano yung component, kung ano magsisilas ng right? Machine design. Tayo pa lang
And alin po ang pwede natin gamitin? AF8 up to AF14. Alin po yung pwede? Anyone? According to Justin, it would be AF18. Yung iba, alin po ang pwedeng gamitin natin?
AF13 po, ma'am.
AF13. Okay, tingnan po natin. Ang pagpipilian lang po is AF8 at saka po AF13. Okay, so puntahan muna po natin yung AF13. Okay, so common po na sagot is yung AF13. Okay, so AF13 would be for a shaft with a radial hole. Ayan. Shaft with a radial hole. So, parehas po ito nung cross-section, okay, nung pong sa given. Okay, parehas po na diameter. Lamang po, ang kanya po na hole ay nandito sa itaas. Dito po situated. So, hindi po natin yan pwede na, atin ma'am iusod, igalaw po natin paharap para mapalagay po natin dito. So, hindi po pwede yun. Okay? Kaya, hindi po natin pwedeng gamitin yung AF13. Although, parang kahawig siya, pero hindi po pwede. Okay? Kaya, ang atin lang pong pwedeng gamitin dyan is yung AF8. Okay? We need to modify po yung AF8 kasi ito po ay flat plate. So, ang gagawin po natin, magiging shaft po siya, okay, with a central hole. So, ibig sabihin, yung cross-section natin, okay, itong cross-section natin, parang gagawin natin below. Okay? So, we need to modify the entire figure. Okay? So, halimbawa, yung x-axis, ano yung counterpart niya kung ginawa na natin siyang below? D over H. So, yung D, hindi naman yun mababago kasi it's the diameter of the hole. Okay? Ano po yung H natin na gagamitin? Ano yung counterpart? This is the height of the blade. So, ano yung magiging height po natin ngayon? Okay? Kung siya po ay shaft na, katulad nito. Ano po yung height niya?
Diameter po ng shaft.
Tama. It's the diameter of the shaft. So, instead na D over H, magiging D over D na po siya. Okay? So, ito na po ngayon ang gagamitin natin. D over D kung siya po ay shaft. Okay? Kung may modify na po natin. Ari na po yan. D over D. Okay? Alin pa po yung ating babaguhin? Katulad po nito. Ari po ay may B over H. Okay? Yung B over H po, ano po ang gagamitin natin siya ngayon dyan? Instead of B over H, yung B po, hindi din naman yun mababago. Pwede mo pa rin po makuha yung distance niya from the left side. So, yun pa rin po ang B. Okay? Correct. So, it would be, yung kay Justin, it would be B over D na po yan. Okay? So, B over D na. Okay? So, you need to modify po. Okay? Para po makuha natin yung KP. Okay? So, ganun lang po yung gagawin natin. Now, we go back po doon sa kanina natin. Okay? So, ito po, sabi natin, pag nakuha na po natin ng KT, then you can find value of KF or KFS. So, masosolve na po natin to be substituted to your solder gauge. Okay? Ito po yun. Yan. So, kaya pa pong medyo pagkakaiba from yung previous natin na without stress concentration, it is only value of your sigma M and sigma A, tau M, tau A. Okay, same equation pa rin naman po. Sigma M is equal to maximum plus minimum divided by 2, and your sigma A would be maximum minus minimum divided by 2. So, same equation pa rin po. Okay? Alin lang yung naiba? Yun po sigma natin. Say, sigma max. Okay? So, kung sa atin po dati, force over area lang ang ginagamit natin. Okay? Ngayon, medyo may pagbabago po. Okay? So, saan po natin siya makukuha? Kasi, yung area po na yun, nababawasan. Kasi meron nga siyang may hole, merong fillet, so mababawasan po yung area. Okay, but then, hindi mo na naman po problemahin yung equation kasi it is included na din po doon sa mga figure. Halimbawa po, katulad po nito. Ayan. Dito po sa figure AF8, meron ka po dito makikita na equation. Yan. Okay? Sigma, ano po ay sigma, although S po yung nakalagay dyan, sigma equal to force over H minus D times T. Ito na po yung gagamitin ngayon natin kung siya po ay flat plate. Okay? H po is the height minus ibinawas po yung hole times the thickness. Okay? So, yan po ang sinasabi ko. Medyo na iba kasi yung area nababawasan with the contained surface discontinuity or stress razor. Okay? Kaya yung equation mo ngayon, okay, sa halip na F over A, ang gagamitin mo, sigma maximum would be equal to F over H minus D times T. And then you'll use here F max. Okay? Kung siya naman po ay F minimum, it would be F minimum over H minus D times T. Okay? So, ito na po ngayon yung gagamitin natin dito at saka doon. Okay? So, ito po at saka yun to be substituted here. Okay? Yan po ay kung figure AF8. Okay? Sa iba naman po figure, naka-indicate din po yun. Halimbawa po, din po sa figure AF9. Yan. Ano po yung sa tension? Sigma equal to F over dt. So, kung maximum minimum po, edi yung pong force ang lalagyan natin. F max, F minimum. Kapag bending, ano po yung gagamitin? 6m over td squared. Okay? If you want sigma maximum ng bending, magiging ano yun? 6m max over td squared. Okay? Kung siya naman po ay sigma minimum, what would be the equation? 6m minimum over td squared. Okay? So, nandito din naman po yung gagamitin nating equation for maximum and minimum. Okay, ito po, tension. Ari po yung bending. Okay? Ari pong iba, yung mga shaft, meron na po siyang torsion. Kita niyo po dito. Yan. Okay, katulad po nito. Ari po yung tension. Ari po yung bending sa shaft. Ari po yung torsion. So, titingnan nyo lang po doon sa problem kung alin yung given. Yung po ba ay tension, bending, or torsion. Tapos, i-apply mo lang po doon sa F, sa M, at saka sa T yung maximum at minimum. F max, F minimum. M max, M minimum. T max, T minimum. Okay? Para po kunin yung sigma M at saka po yung sigma A. Now, kanina po minodify natin yung figure AF8. Balikan lang po natin. Okay? Yan. So, ari po, equation na ari ay para po kapag po siya ay flat plate. Kasi originally naman nga po siya ay flat plate. Pero sabi nga natin, kung siya po ay gawin natin circular, shaft with a central hole, parehas lang din. Pwede pa rin natin itong magamit. Need nga lang po natin din i-modify po ito. Okay? So, ano po yung equivalent niya na equation natin? So, kapag po yan ay circular na, okay, kapag po yan ay shaft na, what would be the equation? Sigma would be equal to F over pi d squared over 4 minus d times d. Okay, ito na po yung magiging equation po natin kung siya po ay circular. Okay, so you take note of this po. Okay, ito na yon instead of this. This is valid only if it is a flat plate. Okay, ito na po ngayon. So, kung kukunin po natin ay maximum, sigma maximum, then you use here F maximum. Kung sigma minimum po naman yan, F minimum po yung gagamitin po natin. Nakuha po ba? Naintindihan po ba?
Yes po.
Okay. So, let us have a sample problem. Okay, ganun po natin siya gagawin. Yan. Okay. So, let us have this. Okay, so a connecting link, okay, is under a maximum load of 10 kips repeated and reversed. Link has a radial hole drilled through it at the center of the section. It is machined from AISI 2330 WQT 1000 degrees Fahrenheit. You determine the diameter of the link for a factor of safety equal to 1.5. You design based on indefinite life and definite life of 10 to the 5th cycles. Okay? So let me have first the illustration of the link. Okay? So you have here the link. Sorry, wait lang. So this is po yung link natin. Circular cross-section. Tapos, meron po siyang hole sa center. Okay? So, the diameter of the leak, okay, this is defined by a big letter D. So, that's the diameter. Okay? Whereas, for the hole naman po, okay, yung diameter po ng hole, say 1/8 inch. Okay, this is given po. The diameter of the hole, 1/8 inch. So, this is now yung atin pong illustration. So, ang hinahanap po natin, what should be this diameter? Okay, itong entire diameter ng link po natin. Okay, so we start with the given values. So, you are given the maximum force equal to 10 kips. Ano pong sinabi doon? Repeated and reversed. Okay, so repeated and reversed load. So, ibig sabihin po niyan, varying po yung load natin. Okay? And then this is also only the maximum. Okay? Kasunod po niyan, we have also the diameter of the hole equal to 1/8 of an inch. In decimal, this is equivalent to 0.125 of an inch. Okay? And then we have now the material specs. We have AISI 2330, WQT 1000 degrees Fahrenheit. Pakihanap naman po ako. What is the sigma U, sigma Y, and the BHN value. Idinadagdag po natin yung BHN kasi yung pong sigma N natin is dependent on this BHN value. Okay? Pakihanap po. I think this is on table 89. And then after the material specification, we'll have the factor of safety. Okay, so for Fs, this is equal to 1.5 and this is given. So given po ito. And then design stress. Now, for the design stress, okay, so titingnan mo muna, ano ba ang aking gagamitin? Is it the Soderberg or the Goodman? Okay? Since this is a variable stress, and then, kunin po natin anong type ng material. 2330 is ductile. And then, ano po yung type ng loading? Action. Specifically, this is tension. Okay? So, use now Soderberg. Okay? So, Soderberg po ang gagamitin po natin. Okay? In what form? Kung axial po yan, so sigma po. 1 over Fs equal to sigma M over sigma Y plus sigma A over sigma N. Okay? Yan po yung gamitin natin kasi Soderberg. Siya po ay variable stress, tapos ductile, okay? Axial, kaya in form of sigma. Okay? Now, meron po siya doon sa illustration po natin, meron kang nakitang surface discontinuity, may hole. So, ibig sabihin, may stress razor, kaya dadagdagan mo yung equation mo ng KF. Okay? So, may dinagdag kang KF to take care of the stress razor. Okay? Oh, so, ito ngayon yung magiging working equation mo po. Okay? So, ang gawin mo, hanapin mo muna bawat component. Okay? Para mas madali mo mamaya isa-substitute. So, isa-isahin mo gaya nung ginawa po natin dati. Okay? O, balikan ko muna rin. Correct. Sigma U is 105. This is 85. And this one is 200. Justin?
207 po.
Again? 21?
207 po.
20 or 20? 20, 21?
20 po.
Okay. 207. Okay, this is KSI. This is KSI. Okay, this is taken from table 89,
89, page
page
17 po.
17. Okay, thank you. Okay, so we have here the material specs and then isa-isahin natin ngayon ito. Unahin po natin yung KF. Okay, this is the fatigue strength reduction factor. Okay, so equation for AKF, this is equal to Q times KT minus 1 plus 1. Okay, be very careful with your equation. Okay, lalo na po pag kinocompute na natin, mag-iiba yung value kung makalimutan mo yung atin po na parenthesis na yan. Okay, so you find first yung Q. Q is equal to 1 over 1 plus A over R. Okay? So, ano po yung value ng A natin? Okay? For quench and tempered steel. Okay? Yun po yung given natin. WQT. Okay? So, dito po siya pasok. Okay? For quench and tempered steel, A is equal to 0.0025. That is from figure AF7. Okay? O, tingnan nga po natin kung tama nga ba yung sinabi ko. Okay? Figure AF7 po, for quench and tempered, 0.0025. Okay? Okay, on page 22. So, yun po ang inilagay natin dito. Page 22. Ayan. 0.0025. So, with that po, you can compute for Q. 1 over 1 plus 0.0025 divided by ano po yung radius natin. Okay? It would be diameter is 0.125, then divide this by 2. Okay? 0.125 divided by 2. Okay? Since it is the radius. So, what is now the value of Q? Answer? 0.9615. Okay, tama. So, 0.96154. Okay? Kung yung kuhanin po natin yung buong value. Kasi ito po ay ating gagamitin pa for succeeding computation. So, dapat yung nakuha po talaga nating value, yun po isa substitute. So, you can save this on your calculator or you can copy all numbers. Okay? Yun po yung gagamitin po natin. Okay? So, ano po yung Q? Next naman po would be the value of KT. Okay? Ano naman po yung value ng KT para ma-solve po natin yung KF. Okay? So, for KT naman po, ang gagamitin natin yung figure AF8 hanggang AF14. So, ang makikita nyo po dito sa illustration natin, parehas po ito ng shaft with a central hole. Okay? So, for KF po, for KT, okay, ito po ay makukuha natin, okay, considering a shaft with a central hole. Okay? So, we can use po central hole. Okay? So, we can use po yung ating figure AF8. Katulad po nung diniscuss po natin kanina. Okay? So, you use figure AF8. Okay? On page 22. Okay? So, yan po yun. Yung shaft with a central hole. Figure AF8, page 22. Okay. So, let us go to figure AF8, page 22. Yan. Okay? So, anong kailangan natin dyan for us to obtain a value of KT? Ito muna pong ilalim, yung x-axis. Okay? Nung minodify natin siya, ginawa natin circular, ano na po itong x-axis? Magiging d over d. Okay? So, yun po yung atin munang kukuhanin. Okay? So, you'll have there d over d. But then, ito pong d na yan, yan po yung ano. Okay? Di po ba itong d? This is 0.125. At itong d na ito, this is ano. Okay? So, kung ito po ay ano, wala kang makukuhang ratio. Okay? Kasi ito nga yung ano, yung diameter natin. So, ang gagawin natin, you simply assume muna. Okay? So, you assume a value of the diameter. Okay? Any value can be an assumption. Okay? But then, sabi ko nga, scientific guess po yung gamitin natin. So, for example, I use here 1.25 inches. I assume diameter 1.25. O ma'am, bakit po alam niyo yung 1.25? Siguro po na-solve niyo na po yan. Kaya yan yung in-assume mo. Okay, paano po kami na hindi naman namin nasosolve pa? So, any number can be an assumption. Okay? Kaya lang, bakit po yun yung ginamit ko? Okay? You look at this po. Di po ba ang hahanapin po natin is D over D. So, kung mag-solve po tayo ng D over D, this is 0.125 divided by 1.25 inches. Ano po yung magiging sagot natin?
0.1.
0.1. Okay? That is the very reason why I use 1.25. Kasi, dito po, merong eksakto na 0.1. Okay? Ari pong linya na ito ay para sa 0.1. So, hindi na po ako mahihirapan na maghanap pa kung saan dito mag-estimate dito ng value ng x. Okay? Kasi yung 0.1 may kanya ng value. Okay? Kaya yun po yung pinili ko. Kaya po ako nag-assume ng 1.25. So, in that case po, dadalhin ko doon sa curve, solid curve. So, I'll have po my KT equal to 2.7. Okay? Ari po yun. 0.1, dinala doon sa solid curve. Ito po yung curve. 3 din po sa kaliwa. So, value is 2.7. Okay? So, yan po yung KT. So, KT equal to 2.7. Okay? But then, it started with this assumption. Okay? Oh, halimbawa po ma'am, ang in-assume ko ma'am ay 1. Assume diameter equal to 1. Oh, pag diameter mo ay 1, so ano magiging sagot mo din eh? 0.125 divided by 1 will yield 0.125. Pagdating mo din sa table, nasan yung 0.125? Are 0.1, are 0.2. So, nasa gitna is 0.15. Nasan yung 0.125? Nasa pagitan pa nito. So, maghihirap ka pa din na estimate, maggawa ng linya para makuha mo yung KT. Eh, yun naman lagi, yung iyong unang assumption, hindi mo alam yan kung tama ba yan o mali. Okay? So, hula lang yan. Mali yan lagi. Okay? So, you need to recompute. Okay? So, yun po yung ibig sabihin ko. Padaliin mo na yung sarili mo na paghanap ng value ng KT doon sa first na assumption mo. Okay? Kaya po, ang ginamit po natin is yung 1.25. Okay? Yan. So, you obtain now a value of KT equal to 2.7. Okay? So, with this value of KT, you can now compute for KF. O, balikan nyo po yung equation ng KF. Equal, thus, your KF would be equal to Q times KT minus 1 plus 1. Q is, ano nga ang value ng Q? 0.96154. KT, you have there 2.7 minus 1 plus 1. So, what is now the value for KF? Find this solve po.
No, kasi pagka hindi nyo natapos, ay mag-extend kayo ng stay. O, magkakaroon tayo ng extension. Hindi ng extension pa,
Again?
extension of your stay sa university.
Ano mga anak, paki-type mo nga sa chat box para copy ko na lang.
Gagawa na ng chapter
2.6346. Okay. 2.6346 okay? O yan. So, yan po yung value natin. Kopyahin nyo na lang po yung mga kasunod pa. Okay? So, that would be the value po. 5385. Yan. So, this is the value of your KF. So, i-box po natin lahat ng component ng ating Soderberg equation. Okay, so KF. Oh, balikan mo yung atin po na Soderberg. Yan. So, may KF na po ako. Sigma Y, Fs. So, ito po pong tatlo. Sigma M, Sigma A, Sigma N. Sigma M and Sigma A, this is dependent on the type of variable stress. Ano po ba ang type ng variable stress natin? Nakalagay po doon, repeated and reverse. Okay? May tatlo po tayong klase ng ng variable stress. 1 is repeated, 2 is reverse, 3 is fluctuating. Okay? So, yun po ay may kanya-kanyang property. Okay? Yan po yung diniscuss natin dati. Okay? But then, this time po, ano po ang sabi? Combination ng dalawa. Okay? This is repeated and reverse. Okay? Repeated and reverse. So, kinumbine. Barkada po yung dalawa. Okay? Dapat isa-isa lang. Repeated lang, reverse lang, or fluctuating lang. Okay? Pero then ito, yan, nagbarkadahan yung dalawa. Repeated and reverse. Okay? So, kapag po nagsama yung dalawa, alin pong property yung will prevail? It will be the reverse stress. Okay? So, reverse will prevail. Okay, so reverse will prevail. So since repeated and reverse will prevail. So what is the property of a reverse stress? Hello? What is the property of a reverse stress? Okay, tama. Sigma M is equal to 0. And what about sigma A? Okay, correct. Sigma A is equal to sigma maximum. Yan po yung property ng reverse stress. So, kung magpasama po yung dalawa, reverse will prevail. Okay? Sigma A equal to sigma maximum. Ngayon, ano po yung equation ng sigma maximum? So, babalikan mo po yung iyong figure AFA. So, yan po ang kukunin mo, yung equation niya. Okay? Na-modify na po natin yan para sa shaft. Ito na po siya. Okay? So, ari po ngayon yung magiging equation. So, yan po ang ilalagay mo dito. Force over, okay, pi d squared over 4 minus d times d. Okay? At ang gagamitin ko po din ay F max since yun po ay equal sa sigma maximum. Okay? F max is given. That is 10 kips. Okay? Divided by, okay, pi d squared over 4 minus 0.125 d. Okay? You try to simplify what is pi over 4. So, this is 10. Ano nga po yung pi over 4? Pakicompute niya po ako. D squared minus 0.125. Okay, so 0.125. Ano po ang din pi over 4? What is the value?
Pumunta doon, mag-browse na. Meron na pala. Gawa na pala. Tingnan ka. Ano ang sila? Ang bago kasi yung natatanong siya. What is new? What is new?
0.7854 po.
0.7854. Tama ba ako? Tama po ako?
Yes po, yes po.
Okay. So, this is now your value of sigma A. So, i-box po ulit natin lahat ng isa-substitute natin to the Soderberg. Okay? So, ano na lang po ang kulang? Sigma N. Okay? Yun naman pong sigma N natin, okay? This is dependent on the life. Okay? So, yun pong ating answer. Okay? Ito pong ating problem. Naka-define naman po A and B on what basis ang gagamitin po natin. So, dun muna po tayo sa letter A. Okay? So, for letter A, indefinite life po. Okay? So, for indefinite life, kunin mo po doon yung equation ng sigma n. Yun po ay doon sa axial or tension. Okay? Axial or tension. O, ano po ang equation natin ng sigma n doon sa indefinite life? O, pakitingnan nyo nga po sa manual natin anong equation ang gagamitin.
Yung pinapasok lang sa hapon ng maximum 545.
Ano po ang sigma n?
Basta hanggang 5. Nasa ang
Okay. So, this is equal to 0.8 sigma prime n times the surface factor. Okay, yan. Yan po yung equation natin. Okay, so tingnan nyo na lang po doon sa notes po natin. So, you get first sigma prime n. This is the endurance limit. Okay, this is simply equal to 0.5 of sigma u. Why? Because the BHN value po nito, okay, ang BHN po niya is 207. So, less than 400. If BHN is less than 400, you use 0.5 of sigma u. Okay? BHN less than 400. Okay? So, this is 0.5. What is sigma u? 105 KSI. So, that will give us 52.5 KSI for your sigma prime n. Okay? And then for your value of the surface factor, okay? So surface factor naman po, we should know the type of surface. Ano pong sabi doon? It is machined from 2330. Okay? So we have here a machined surface. Ano pong figure yung kukunan natin para sa surface factor? Hello? Alin pong figure ang gagamitin?
AF5 po.
Page 21.
Okay, AF5. O punta tayo doon sa AF5. Yan. Okay, this is figure AF5 wherein you can obtain the value of your surface factor. So, ang kukunin po natin dito is yung sigma u sa x-axis. So, ang sigma u po natin is 105. Okay, ari po yung sigma u natin sa gitna. Okay, so sigma u is equal to 105 KSI. So, gitna po yun. Tapos, dini po sa machine. Okay, that will be our type of surface. Okay, so ito po yung value niya. Tapos, kunin lang po natin ang value po dito. Okay? Okay, so approximately, ano pong makikita natin dyan? 85%, or this is simply equal to 0.85. So, yan po yung ating magiging value ng surface factor. Okay, so approximation lang po ulit yan, yung 0.85. Okay, so yan po yung substitute po natin. Taken from figure AF5. Ano pong page na rin?
21 po.
Again?
21 po mo.
21 po.
Yan. Okay, that would be the surface factor. And then you substitute them all to sigma n. 0.8. Sigma prime n is 52.5 KSI. And then the surface factor 0.85. Okay? What is now the value? Ano anak? .7 KSI for your sigma n. Right? Doon sa letter B, pag naging indefinite life na yan, so iba naman yung i-equation mo. Ari po ay magiging sigma n1. So you have to compute for sigma n1. Okay? Yan. So, kompleto na po yung ating components ng Soderberg. So, what you will do is you substitute. Okay? Substitute to Soderberg equation. Okay? So, kindly substitute to the Soderbergh equation. 1 over factor of safety, 1.5, equal to sigma n is 0 over sigma y, 85, plus kf. Okay, you have here kf, 2.64, 2.6346, okay, times sigma A. Okay, ano po yung sigma A natin? 10 divided by, ano po nasa ilalim? 0.7854 d squared minus 0.125 d divided by your sigma n, 35.7. Okay? So, yan po yung isi-simplify natin. 0 over 85, this is 0 already. Okay? So, we yield now 1 over 1.5 equal to 2.6346 divided by 35.7. Sorry po, nilagay lang natin. Okay? Multiplied by 10 divide 0.7854 d squared minus 0.125 d. So, you try to simplify now po. Okay? So, ang gawin niyo po, ay divide natin, tapos i-transpose po natin to the other side. Then, you cross multiply. Okay? So, ang makukuha niyo po dyan is a quadratic equation. Okay? Kasi po ano po ay may d squared tapos may d. So, makukuha mo po siya dyan ay quadratic equation. So, pag na-simplify mo po yan, it will lead to a quadratic equation. So, ilalagay niyo po dito ano yung quadratic equation natin. Halimbawa, 0.7854 d squared minus 0.125 d minus ganon equal to 0. So, that is our quadratic equation. Okay, so you try to simplify. And then, by quadratic formula, okay, by quadratic formula, yan, alin po yung quadratic formula? Yung negative b plus minus square root of b squared minus 4ac all over 2a will obtain the value of the diameter. Okay, ano po ang sagot natin? Pakicomplete nga po ako. Oy, anong sagot? 1.2694. Correct. Okay? 1.2694 inches. Okay? So, this is equivalent to 1 and 3/8 of an inch. Okay, now, hindi pa po natin alam kung tama yung sagot natin na yan. Okay? So, paano po natin malalaman? Babalikan mo po yung assumption mo. Okay? Ay po yung inassume natin. Assume D equal to 1.25 inch or say, this is 1 and 1/4 of an inch. You look at the standard size. This is 1 and 1/4. And the standard size of our answer here is 1 and 3/8. So, magkaiba. So, ibig sabihin, hindi pa po tama yung sagot mo po. Okay? Masasabing mo lang kung tama yan kapag parehas po yung kanyang standard size. Okay? O pasabi, ay 1.25 na yun ma'am, ari ay 1.27, ang lapit-lapit na. Pero magkaiba pa rin yung kanyang standard size po. Okay? Kaya you need to recompute. Okay? So you need to recompute. Okay? So saan ka babalik pag nag-recompute ka? Dito ka po babalik. Okay? You would have another assumption. Okay? So you assume a different value. Para lumapit po yung answer, ang gagawin mo, ang assumption mo ngayon, yung naging sagot mo kanina. Okay? 1.27 inches. Okay? 2694, 1.27 na ang gagamitin mo. Kasi, gagamitin mo rin naman po ay figure AF8. Okay? So, sa figure AF8 po, hindi mo naman mababasa yung 1.2694. Katulad po na rin, balikan po natin yung figure AF8. Yan. Yan. O, saan mo po diyan makikita yung yun pong ating value. Okay? Kasi, kamaga, ang kukunin mo po dyan is still D over D. Okay? So, ari po ay magiging D natin is 0.125 divided by 1.27 inches. Yan. So, makakakuha ka na po ng bagong answer. Nakuha po ba? So, parang gagawin mo lang po ulit. Ito lang po ulit yan. Okay? So, makakakuha ka na ng bagong D over D. Babasahin mo ulit yung bagong KT. Tapos, magsusolve ka ulit ng panibagong KF. Okay? So, meron kang bagong D over D. Tingnan mo yung KT from figure AF8 page 22. Okay? Tapos, pag may bago ka ng KT, you solve for the new KF. KF is equal to Q times KT minus 1 plus 1. Ang KT na gagamitin mo dito ay di ito na po yun. Okay? Nung nagbago ka na ng assumption. Okay? So, you would have a new value for KF. And then, ano kung isusunod mo dyan? Pag may bago ka ng value ng KF, you substitute again to Soderberg. Okay, you substitute again to Soderberg. 1 over Fs equal to yun po kanina. Okay, na-eliminate na po natin yung sigma M. Okay, magiging sigma A over KF sigma A over sigma N. In-eliminate ko lang po dito yung sigma M ha, kasi yun po ay 0. Okay, kaya naging ari na lang po. So, the same value pa rin po ito, yung sigma A, yung sigma N, Fs. So, ang tanging mabago lang po ay yung KF. Ito na po yung gagamitin natin. So, you would have a different value of the diameter. So, titingnan nyo po ngayon itong diameter na ito. Okay, kasi ari po is 1 and 3/8. Okay, so dapat po yung diameter na to, okay, this should be 1 and 3/8 din po. Para po, yun na yung maging final answer natin. Therefore, use diameter 1 and 3/8 of an inch. Okay? So, inyo po yung i-recompute. Okay? I-recompute nyo po iyan. Tapos, tingnan nyo nga po kung ito nga po yung sagot. Ang magiging sagot nyo po isang ano po dito, malapit po sa 1.27. Okay? So, i-compute nyo po, tapos tingnan nyo nga po kung tama. Okay? So, ito po yung magiging answer na po. Okay? So, ganyan po yung gagawin natin. Okay? Hindi mo po tatanggapin yung value not unless they have the same commercially available size. Okay? May question po kayo? Naintindihan po ba aring pagre-recompute? Hello?
Yes po.
So, ang tangi lang pong nababago pag nagre-recompute ay yung pong KF. Okay? Kasi nag-assume ka ng bagong diameter. Okay? So, KF po ang mababago doon. Kaya lang, isa-substitute mo ulit sa Soderberg equation. Okay? Yan. Tapos po, now, yun pong ating solution na yan, okay, yung answer po natin yan is only for one stress razor. That is po na dito sa sample problem po natin, iisa lang yung stress razor natin. So, yung mahabang solution natin yan para lang dito sa hole na yun. Okay? What if ang ating pong machine member ay ganito? Yan. Ano po, multiple stress razor. May hole, may groove, may fillet. So, yung answer po natin ay di para lang po dun sa hole. Halimbawa, ang nakuha natin ay 1 and 3/8 of an inch. Halimbawa,
Okay.
yun. Okay?
Rest.
So, meron po tayong magiging answer ulit sa groove doon sa fillet. So, magiging solution nyo po, if it contains several stress razor, okay, edi iaano po yan per stress razor. Halimbawa, consider hole, okay? Consider the hole, you obtain a diameter 1 and 3/8. So, ari po yung procedure natin, yung parang yung ginawa natin. So, yung ganyang kahaba, yun po yung equation, yun po yung para dun sa hole. Okay? Tapos, magsusolve ka po ulit. Consider naman po yung other stress razor. Halimbawa, consider groove. Okay? What would be the diameter? Kung ano man nakuha mo dyan. So, ganyan po ulit yung procedure mo. And then, another one would be consider fillet. So, meron ka pa ulit diameter considering the fillet. So, iba-iba po kasi yan kasi iba-ibang figure yung gagamitin mo. Are, ginamit mo figure AFA. So, are, anong figure yan? Anong pong figure para dun sa fillet? Okay? Nakukuha po ba? Oh, kung ari po ay circular cross section din, okay? Ari po ang gagamitin natin sa groove would be ano po yan? Yan po yung figure AF 14. At ari po yung figure AF 12, okay? Yung para sa fillet. Tingnan nyo na lang po kung okay? Tapos, tatlo po yung naging answer mo. Ano po yung magiging conclusion? Therefore, use the, it should be the largest value. Okay? Kung ano po yung biggest among these three, that would be your final answer. Naintindihan po ba? Hello? Nakuha?
Yes, pero
Per stress razor po yun ha, per stress razor. Kasi wala po tayong figure, okay, ng na barkadahan yung stress razor. Okay? Isahan lang po. Kaya ang ating po solution, edi isahan din po. Then you have to consider all stress razors. So, per stress razor, may sagot po tayo. Okay? So, yan po ang ating variable stress analysis with a stress concentration. Any question?
Nandun po sa ano,
Yes pa.
hindi po pwedeng mag-shipsod na
Saan?
yun sa pagkuha na po ng diameter.
Dini po sa, yung po sinasabi mo, yung sa pagkuha ng diameter. Okay, ano po ba yan? Wait. Yeah, that is when we have yung quadratic. Ari po ba? Tama? Yan.
Apo.
Oh, pwede naman, dini po, after po na rin, di ka po ang sabi ko sa inyo, ilagay nyo lang po dini yung quadratic equation, yung simplified form po na rin. Halimbawa, 0.7854 d squared minus 0.125d minus, halimbawa ay, arila po sample lang ha, hindi ko po alam kung tama. Halimbawa, minus 38 equal to 0. So, this is your quadratic equation. Okay, so hanggang dini po. Tapos you can state there na lang po, by quadratic formula, what is the diameter? Di ka po dito kayo nag-shift solve. Pag na alam nyo na po ito, di ka po, naintindihan na po ako. Ito po yung negative b plus minus, di ba? Di po ba ito ang a, ito yung b, ito yung c. So you need this, okay? You need this quadratic equation, okay? Tapos you simply state by quadratic formula what is the diameter. So at least man lang po, I can see the quadratic equation. Nakuha po, naintindihan?
Oy, birthday ni... Oy,
Hello?
birthday ni...
Okay po, ma'am.
Hindi ka nagpamisa.
Hindi po pwedeng pagkatapos na ay diameter na. Hindi po ako papayag ng ganoon. Okay? O, kaya po hindi tayo natututo kasi even the basic ones ay hindi po natin ginagawa. Okay? So we should know the quadratic formula. Okay? Kahit man lang mag-arrive ka dito sa quadratic equation, I want to see this equation. Okay? O, the simplified form of it. Tapos po, what is the answer? Any question pa po? Yes po. Sige po.
Ma'am, sa pagre-recompute po ba yung KF lang po talaga yung nagbabago?
Oy, birthday ni Albert
Sa pag-recompute po, yung KF lang ang magbabago.
And yung
Kasi,
ibang values po
nag-assume-
retain po.
Retain. Kasi ang inassume tayo, ang ina-assume po natin ay na diameter or any dimension, gagamitin mo lang po yon to solve for KT.
Okay po ma'am, thank you po.
Okay.
Kaya magpapamisa tayo.
Not unless, okay? Okay. Not unless po, di po ba? Dito po kasi hindi tayo gumamit ng size factor. Dini, okay? Dini po sa indefinite life. Di po ba merong may equation na may size factor na 0.85. Okay? Mapera po may ganun. Okay? So we need to recompute kapag may size factor. So halimbawa po, kung gumamit ka ng size factor doon, mababago yung sigma n mo. Okay? Kasi magre-recompute ka ng sigma n. So ang mababago mo ngayon ay dalawa. Okay? Alin ang mababago? Yung KF at saka yung sigma n. Kasi may size factor kang ginamit. Okay? Kung hindi siya pumasok doon sa range na 0.5 up to 2 inches.
Puro mga exhibit.
May question pa po? Nakuha po ba yung sinagot ko? Hello?
It's the 5 days.
Yes po ma'am.
Okay. Pero kung wala ka namang size factor na ginamit, yun lang po. KF lang po yung mababago. Para po lumapit yung answer, ang gawin nyo nga po, yung una nyong sagot, yun yung sunod nyong assumption. Pag malayo pa din, edi yun pa uli. Yung naging sagot mong huli, yun po yung iuling i-assume hanggang sa lumapit na yung value. Siguro naman po ay bago matapos yung 3 oras, edi nakuha na natin yung sagot. Question pa pa? Wala na? Wala na po ba? Hello?
Wala na po, ma'am.
Okay, wala na. Okay, so sige po. Ang ating po exam ay hanggang din po ha sa with stress concentration. Okay, so I'll stop the presentation now. Thank you for attending our makeup class. Ako lang po ay hindi naka-attend sa inyo kahapon because of yung meeting, and at the same time ay hindi ko rin nadala itong aking laptop kahapon. Okay? Yan. So kaya I ask Alma na magklase po tayo ngayon. So thank you very much po. Okay? So pasuyo lang po ako ng attendance check natin. Alma, pasuyo.
Yes po, ma'am.
Open your camera, everyone. So if you want, I can send po sa GC natin yung yung lecture po natin with the doodle. Okay, para po mabalikan ninyo. Okay? Kasi save ko na lang. Ituloy nyo yung ituloy nyo yung pag-solve dun sa problem. Resolve at saka yung letter B in definite life. Okay na?
Intercourse daw eh.
Alma, okay na?
Yung picture po, 1, 2. Sama po. 1, 2.
Okay. Thank you.
po.
Bye po.
Thank you po, ma'am.
Thank you po, ma'am.
Okay po ma'am.